Welcome, this is where nerds come to learn things. If it's your first time here, click on the subscribe button and on the bell icon to get notifications about new videos. Thanks for watching, hope you enjoy it. Here's the SDS2352X-E, the new scope, which is 350MHz 2-channel. It's got MSO capabilities, 2 gig samples per second, stuff like that. So it's a pretty advanced little thing. Now, this is from Rob, Tobacco Technologies. If you're in New Zealand and you're interested in one of these, then this is who you need to contact. This is on loan from him. So it's got a 7-inch TFT LCD. It's a 350MHz in this case. There's also a 200MHz version. They're both 2 gig samples a second. That's split across 2 channels. So if you've got 1 channel running, you get 2 gig samples. If you've got 2 channels running, you get 1 gig sample per channel. It's also 110,000 waveforms per second in normal mode, and I think it can do up to 400,000 waveforms per second under a certain condition. I can't remember what it was now. 28 megapoints memory depth, or 14 per channel. Now, it depends on what settings you've got at the time, but 28 megapoints is like the maximum it can do. Arbitrary waveform generator is an option. You can get a plug-in unit which plugs into the USB here. It's USB control. You would have seen that in the previous video I did on the SDS1104X-E. I think I got that number right. If you haven't seen the video, I'll probably link it in like up there somewhere in the corner, and definitely be down in the description as well. I'll link to that video, which has a lot of similarities to this particular scope with the AWG option. You can use that for doing BODE plots as well. So the AWG is an option. So I think it's a software upgrade and a piece of hardware as well, which obviously you plug into the front to give it the AWG. The number of that is an SAG1021. There's also the BODE plot option, which you need the AWG for. Again, that's an optional feature which gives that phase stuff. Again, that's covered in the SDS1104X-E review, which I did about a year ago now. It does 1 megapoint FFT as well. So obviously inside the math functions. MSO, which I've already mentioned. That module for the MSO is an SLA1016, which is a 16-channel digital module. So you can read 16 channels on that. It has an anti-alias filter. I need to actually look into this and figure out what this is. I'll probably try and find out before I finish the video and add that in when I'm going through the menus. But I saw that in the menu system and thought, oh, I wonder what that is. I need to actually find it out. Also has a built-in web server, so when you're using the networking, like the Lan Interface, which is on the back, which I'll show you in a second, you can interface to it from a computer and go to its built-in web server and control the device and view the screen and stuff like that using a web server. Also, unlike the 1104, these inputs, it's a bit of a giveaway just here, 1 mega ohm and 50 ohm. So it actually does true 50 ohm input matching. Whereas the other one was just a display, like a calculation for the voltages and stuff like that. It didn't actually change the impedance on the input jacks. So this actually does switch. You can hear relay switching, and it does true 50 ohms as well. So when you switch to 50 ohm input, it is actually 50 ohms on these. And it's got USB Wi-Fi, so you can plug a Wi-Fi module. I think it's in the front or the back. I think you plug it in the back as well, which is a TLWN725N. But I believe there's other units you can use as well. That's the official one, but I think there's actually another one you can use, which I think I mentioned in the 1104X-E review as well. I'm pretty sure it's in there. Okay, so let's have a look at the back. Then I'll come back to the front and cover a bit more detail. Obviously, one of Rob's stickers there. This is one of his demo units. So it does 110 volts, 240 volts, 50 to 60 hertz, or 400 hertz at 100 to 120 volts. So it's obviously switch mode power supply built in, you know, as standard these days. External fusing, and then over here we have Lan Interface, as I mentioned. We've got a USB, was that B, is it? USB A, and pass fail and trigger output. B and C connection just there. It's got 3 USB ports. So on the front you've got all the standard controls you normally expect to have. So we've got the power button down here as you expect. It's got a menu button on off, which hides some of the menu system. Soft buttons over here, print button. You've got the probe compensation test point. You've got the multifunction dial up here for doing various setting adjustments. Channel 1, Channel 2 selection. Cursors measure, acquire, display and persistent settings. Utility, save and recall. Clear sweeps. Serial decoding, which comes as standard. That's not an option, that's actually standard built into it. Run stop obviously. Auto setup default, history, which goes through the step menu, which has got also the segmented memory, right, and you can step through as well using those. Navigation button, trigger setup stuff, and auto normal single as you expect. Trigger adjustment, which also has push button function, so you can center it. Horizontal position, search and roll options as well, and position adjustment, and also centering when you push it. All these buttons are push as well, so if you push them, it centers them all. Well, that's, in that case, it's a selection. Vertical adjustment, obviously levels, pushing for fine control usually. That pushing it horizontal gives you a zoom option, which I'll just tip that back a bit so you can see it. Okay, so there's what's underneath those knobs there. So you've got variable and zoom, and these ones here, obviously the zeroing as well, so it centers the positions, and trigger 50%, as you can see there. Okay, digital. So if you've got the MSO option plugged in, you can push that button and you get sort of digital channels up. And obviously you've got that option installed in the scope as well. And we'll go through the menus and cover that stuff. Also it's got reference and mathematical functions as well. I should mention that, I didn't mention that before. So you can do reference waveforms, and under math menu you can do things like the FFT, for example. Okay, so let's plug this thing in and take a closer look. Okay, just turn it on. Take a bit of time. So about 20 seconds, thereabouts. Not that bad. I've certainly seen a lot slower than that. So there we go. Obviously I've been playing with this thing already, so it's not like default settings, stuff like that, so it's, well, yeah, let's push the default button. Let's go back to the default settings. And it's already set itself up. Using it is pretty simple. Obviously you've got 2 channels. Let's see, channel 2 is now on. Let's just move it down a bit so they're not overlapping. So both channels is turn, you know, on and off as you want. Okay. As you typically get. Math functions. Let's do addition I think right now. So we've got operator plus over here. What functions got here? You've got plus, minus, multiply, divide, FFT, DDT, FDT, square root. I don't bloody know what the other ones are. I don't use math functions typically myself, but FFT I used, and the positive addition, and I think I'll use multiplication as well at some point. So let's go down to FFT. I select that, and there's an FFT display based off channel 1 currently, which has got no input obviously. Set the frequency, you can choose whatever you want from there, within range. Yeah, 0. That's the thing I get there, it's knobs. Always go right to increase, the right reduces. You go left to increase. To me that's like backwards. I'm always doing it on all the silicon scopes, I always do it the wrong way around. Even my one I've been using for ages, I still do it the wrong way around. To me, turning up is going to the right. I don't know. Maybe if you're left-handed it'll be different, I don't know, but yeah. Anyway, so centre, going the wrong way again. Right, so that showed up to 500 MHz centre position there. So in theory it should be able to receive up to 500 MHz. We'll try that out, we'll chuck the signal generator on it and we'll actually play around with that. Span basically, horizontal division, or hertz per division. So you can go, you know, right down to, what's that, 12 or something, is it? Let's bring this right down. Let's make that bigger. I can turn this one down more, a bit quicker. Look at that, centering, minus 1.6 GHz. Showing gigahertz. I don't think it's going to read that high up though somehow. It's going to have some kind of limits. Centre 2.75 GHz. Don't think so. It's the vision. Let's put this back down again. Alright, so you can go right down to 12.2 kilohertz hertz per division. Scale dB. You adjust that range, reference level. So you can adjust that one. Shifts the range on the display. Hope you can see the graticle okay. It's quite bright around here. I think I did actually have it turned up, but I might have to look at that. Make the graticle a bit bigger. Display. Right. Intensity, yeah, there we go, it's all turned down. There we go, turn up a bit. Now you can see it better. Intensity, turn up a bit as well. Because I've got really bright lights, it makes it hard to see. I can see it fine in real life, but obviously because of the lighting, it makes it somewhat harder. So now you can definitely see it. I've cranked it all right up, so that's fine. I could see it fine before. So that's what the menu does, it turns all this sub-menu stuff here off. Because I think you can have stuff down the bottom of the screen there. Okay, so back to the math function now, you can actually see the screen a bit better. So, actually you've got these digits down here, you can't really see where it's going on. Let's go back into there as well. So the transparency? No. No. I was trying to see if I can get those digits there, there's light more. See now, in these settings, going right is increasing it. Alright, which is what you'd expect. I don't know, it's just little, to me it's little firmware quirks. I think I prefer to have it so as you turn it, the value increases. I don't know. Obviously the way I do the FFT is actually moving it left and right, which is doing the opposite to the actual value. I'll get better math. So I've got those different modes, so split screen, full screen, so it covers the whole screen, exclusive, so it turns the actual traces off, so you can choose how you want to display the FFT and what have you. Where I set automatically to choose what ranges to use, and you've got different kinds of sensing, like normal, max, hold and averaging as well. You can set the manual of averages, number of averages you want, and you can reset it too. So I'm not sure what the range is on this. 4 minimum looks like, and maximum is 1024. So that's normal again. Alright, window type, so rectangle, Blackman, Hamming and flat top. I don't really know much about FFT stuff, so I can't tell you too much about what those actually do. I would have to research it, and to be honest, I think you should research it if you don't know, if you're interested in what it is. Okay, so reference waveforms as well, you can do that stuff in here too. You can choose a channel and say you've got reference waveform and tell what you want it to be, and just save it and display on off. I haven't got one saved yet, have I? So there you go. So now there's the reference waveform there in the blue. Alright, and scales and stuff like that, so it's all pretty standard stuff. Roll mode, so it just, as it does, roll mode runs across the screen. I think it's pretty much regardless of what your horizontal time base is set to. So I can only go to 1 second, the division, as you can see, but I can go right up. So roll mode turns off automatically at a certain position. Let's find out what that position is, shall we? So that's at 20 milliseconds division, but then I can turn it back on. But each time I go up, I have to push that button again. You can't really see these do illuminate, you can't really see it because the lighting's so strong, you can just see there it's green. But it turns off when I'm going, increasing that time base. But I can put it back under roll mode, even at that time base is 50 milliseconds the division, and I can still put roll mode on. So what I think I should probably do actually is chuck a waveform into this of some kind, and actually something to look at apart from a couple of lines on the screen. We'll do that. I'll generate a signal with one of my other generators and shove it in there, and then we'll do some measurements and stuff with it and just look at it a bit more better that way. Okay, so I've set up a basic waveform. I've got a 1 kHz, 1 volt peak to peak sine wave going in, as you can see. How accurate that signal is as far as levels and frequency goes, I'm not entirely sure. It's just been generated by my Keysight oscilloscope in this case, so it's got a generator in it. So is my other Siglent actually, but I'm set to use that one because I can get to the front a bit easier right now. And so that's what I'm generating, and you can see on the front here it's doing about kilohertz up here. If I actually reduce the time base, it should make it a little bit more accurate actually. And you can actually see the trigger points up here. Okay, so it's searching for trigger points. So each time it does a zero crossing, it puts an arrow up, see that? So that's what that's actually doing, is showing the zero crossing point for where the trigger is. If I adjust the trigger, was it still doing zero crossing? It's still doing zero crossing. So yeah, it's staying at zero crossing point. Alright. But then it might be able to do a different way as well. So you can do rising and falling edges. Okay, so sensing the edges at a zero crossing point. And thresholds, so you can probably set a level here Let's have a look. So at that point there you can actually set where it's sensing. So I see I've got it, you know, nearly half a volt there, which should be right at the peak of those, which you can see there. It's starting to just flick around a little bit where it's on the edge. So put it back to 0. Okay, so that's what the search does. It shows you what a 0 crossing is in this case. Turn it back off, don't want to play with that now. Alright, so cursors, typical cursor setups. You've got manual and tracking cursors as well, so it follows the waveform and matches it. So it automatically gives you data in here. But what it's doing, it's all going to be hard to read for you right now because I've got the intensities all turned up to make it easy to see on camera, all the other stuff, so it's going to be sort of covered a little bit there. Just see if I can improve that slightly, shall we? With transparency. Back to cursors. Now, so it's giving you data there about what it's actually measuring. You can tell it what kind you want to measure, the source obviously, and you know the actual cursor types. So if I do manual cursors again, you can choose what values you want to measure. In this case, I want to measure X. I'll just do that across there, and then you can adjust the cursors to be where you want. In this case, I'm adjusting both at once. Right. So if I stick on that peak there, click it, and I should be able to manually adjust one at a time. So now it's only moving that one. So I'll stick that there, click it again, let's jump to the yellow one. I can then measure that peak there. If I just do a single peak, it should then give me some data about the actual waveform a bit better. Like that. And it'll tell you here it's telling you the delta frequency, which is 990 Hz in this case, because it's obviously I haven't got it quite in the right place. And obviously the actual time as well, delta time. And positions relative to the trigger point, which is in the center, obviously because I've gone to the left, it's off a little bit there. Okay, so obviously that's that type. Also you've got Y as well, so you do the same thing for the vertical offsets and the vertical measurements. Or you can just do both, and it will do both measurements at once for you. Alright, also you've got the tracking again. So let's turn it back off, and I'm going to use it right now. Measurements. This is probably the feature I use a lot on my own scope. I find it really handy. So you can turn statistics on and off, and it shows up down the bottom of the screen here. If I turn the menu off, it drops it down. You can see along the bottom there, so it's not actually interfering with the waveform. It just pops it all nicely out of the way. If you've got a lot of big waveform where you've got, say, you've got both channels running, you've got one above the other, for example, so you're not overlapping, you might need that real estate on the screen. So when you pop that down, you can see it a lot better down there. And you can set various functions in here too, what you actually want to look at. You can go to types, so you can choose which ones you want. So I generally have peak to peak, RMS, and frequency. I don't tend to use period, not for the stuff I do, not often anyway. But these are ones I tend to use, okay? Yeah, let's do that, there we go. So now you've got these other measurements down here as well, so now you've got peak to peak, RMS and freq sitting down there. Right, nice and tucked out of the way. There's also the all measure as well. Get my hand out of the way, so you've got all measure as well. That's another handy one if you just want to do a little quick measurement. So you push that one on. And up here, again, it's washed out because I've got everything turned right up for the recording process. It tells you everything. All the measurements it can do, it just tells it in one go for you. So if you just want to quickly look at something and not keep it there, you want to quickly check a measurement or whatever, whatever it may be, you can then do that and it'll pop it up for you and you can see what it is. Alright, and back down to that again if I want to do that too. Okay, so it's got peak to peak, top voltage, standard deviation, VOV, I'm not quite sure what it means, 1.6 or something percent it's doing there. It's got all sorts of stuff here which I don't actually know what they are. Frequency, full, delay, bass, max, min, C standard, some other stuff I don't know, mean, yeah, anyway, so lots of statistical information there which are handy to have. Gate, means you can delay the actual measurement timing if you need to. It's not something I've ever used, to be honest. In fact, I'm not sure I've noticed that before. My other scope, maybe it is there, I'm not sure, but it's not something I've noticed and used myself. Okay, so that's the measurement side of things. I think I've covered that. Also, you can change channels or which which option you're using. If you've got both channels on, like I've just turned the channel 2 on now. Oops, I'll just come back to input sources. So then you choose channel 1 and channel 2. Now if you're in a math function, you should be able to do measurements on math as well. And those functions there, and use it off that. Okay, let's turn channel 2 big. I'll begin to tidy the screen up. Core menu, so acquisition modes, normal, peak detect, average and ERES. I tend to pretty much use normal all the time. I very rarely deviate from that. If anything, I might go to average, but that's pretty much it. XY mode, so you can do that option instead, so you got those, use both inputs to do that kind of mode. Sequence settings, so if you want to do acquisition on using sequented memory, you can do that. You can choose how many segments, or somehow, I don't know, another thing I don't tend to use. Maximum depth, so this is at 28 megapoints as I was saying before, and it goes down to 28k. It depends on what your horizontal time base is set to. So if I change this, so it says 28 basically all the way, but also depends on how many channels you're running at the same time, and a few other features, you know, whatever you're running at once, that will drop down depending on certain circumstances. I can't remember what they are exactly, but generally it's, you know, it's max anyway. Interpolation, Silent X and X. Acquisition mode, fast, slow. Anti-alias filter, that's that thing I found before, which I don't know what it does yet. It will do something. I don't know what yet. So display settings, I kind of went these before. So type vectors or dots, color gradients on and off. So you can do gradients depending on what kind of signal you're coming in, and persistence as well. So infinite right down to, is it 1 second? This is the lowest it'll do. Right. Which means you've got a, like a, say for example, an amplitude modulated waveform you're trying to measure. You can actually see the occurrences quite well. Or if you've got a glitchy kind of signal coming in, you can also use that persistence to actually catch it, so it will show up in the waveforms on the persistence. You know, if it's so fast you may not see it, or may not be able to trigger it very reliably, then it's a nice way of catching those kinds of things. Let's give it down to off. You can also do it from here as well. So obviously this is where I was before with setting the intensities and stuff like that. So you can choose grid types too if you want, depending on what you want to do. Okay, so that's pretty much covered that part. Save and recall, so if you've got a waveform and you want to save it, you can do that. You can just save it if you've got a memory stick plugged in, like a flash drive or something like that. I think you might be able to do it over LAN as well, actually, I'm not sure from memory. Save to external, save to internal. So it's got internal memory as well. So you can save setups, references, bitmaps, JPEG, PNG, binary, CSV, MATLAB, or to default key. So if you've got a configuration you use frequently, so if I wanted to use this setup over and over again, right, it's always wanted to be set up the same way. I choose to default key and press save. When I hit default, it will return to those same settings. Okay. You've also got factory setup or current setup as well. So you can, if you want to return it back to original, you still keep that, but you can come back over here and return it back to factory setup. Alright. I'm not going to do that right now. I want to show you this works. Okay. So let's go. Let's change some settings on here. Drop that down. Drop that down. I think I must have some persistence still going on there. And let's do a default setup again, and it should go back to where it was just then. It does. Kind of. I've got persistence on still, haven't I? Yeah, still persistence turned on. That's why it looks looking like that. I turned it off. Let's go back to the save recall again. Let's resave that again. Can't set up. Right, done. So if I change this again, that should be a bit tidier at least. Alright. And there you go, back to the setting I had. Alright, so that's a nice little feature if you have a setup you always use and you don't want to mess around configuring it all manually and getting your time base and stuff to set up, just save it as a default and boom, off you go. Alright, nice little feature. So other things we've got under the save recall, so you can recall things as well. So you can save setups, reference, which is obviously the pass-fail stuff I think as well, reference waveforms, fetcher defaults, or security arrays, which is a, I don't know, I think some military requirement I think. And you can recall from external or internal, and you can choose which setup you want to use as well. Clear sweeps, so I don't know what it does. Never used it. All right. Decoding, obviously you got that in there. Actually, I'll come back to utility first. Do that one. Cover that. So system status tells you information about the unit. You have to push the single button to get out of that, which is over here. Self-cal, which you should only do after a period of time. After it's had a long warm-up period, you don't want to do a self-cal when it's still cold and settling down. You know, as it's warmed up, then you do a self-cal. I think they recommend an hour. I can't remember what it says now. Quick cal, that's on, but it means if it detects or thinks it should do a recalibration of a particular mode, it will do that automatically. Sound, so it's the beeper, so you hear me beeping when I'm pushing buttons. If that annoys you, turn it off. Personally, I like it as a nice confirmation that the button's been pushed and it's been activated. That way, if you've got something which isn't quite working the way you expect it to, or you're doing something wrong, at least you know the button is actually working. It's not just the button not working. You end up pushing it harder, which is not good for the buttons either. Language selections. So these are the languages available. So is that Chinese, Japanese, maybe, I don't know. Is that Japanese there? French, Korean, I think. German, Spanish, Russian, Italian. Those are the ones I can see anyway. Next page. Pass-fail settings. So you can choose that, what you want to do with those. I haven't created a mask yet, so I'm done with that. Mask settings, so you have to create a mask, and say if I wanted that to be a mask. So let's go back here, turn it on. I don't know. I don't use pass-fail myself, so I need to. Back. Comes from page. Pass-fail. Mask setting. And I create mask. Load it. Back. Operation on. Now it'll do it because I've loaded it. I'll just tell you the deviation, I suppose. I don't know. But yes, that's pass-fail stuff anyway. Turn it off. And I go over here. So stop and pass-fail. Beeper as well, so if you've got a failure, it'll beep at you. That sort of stuff. Okay, next screen. Updates, so it's doing firmware updates. And you need to have a flash drive plugged in for that, right, because it loads off the flash drive. I think you can also do firmware updates from the software, as it, I think it's called Easy Scope. I think it's called Easy Scope, the software, and I believe it actually does firmware updates from there as well. Or maybe through the web interface, and can't remember exactly. Self-test, so if you want to test stuff out, you can test screen, keyboard, LEDs. Expecting something's not working right, you can do that and verifies it all. So if I did a keyboard test, for example, it shows you all the digits. Although you can't see it very well on camera, you push buttons, it lights up and just confirms that those buttons are working, or dials are working, that kind of thing. You know, it does all that. So if you've got something which doesn't appear to be working correctly, you can verify whether the actual unit is seeing the button press. Because failures can happen over time, you know, a few years time, or 10 years or 20 years or however long it lasts, I don't know. Get out of that. Also other tests as well. Screensaver on and off. You can choose if you want a screensaver on or not. I personally don't. Maybe you do. And these are options. So waveform generator, USB, Wi-Fi, and MSO. So information currently is that it's got temporary licenses because this is a demo unit, and none of these have been used yet. So it's got temporary licenses on it. I think you get these anyway when you buy the unit. I think you've got a temporary number where you can try things out. But so you need the AWG and the MSO options. You actually need the hardware for those functions to work anyway. So if you've got those, chances are you've got a license anyway. So USB Wi-Fi, so you can probably get some other USB dongle and plug it in. I did mention in the previous video for the SDS1104X-E, when I did that review, there was another dongle you could use which worked. So have a look at that video if you're not sure. And if you want to install licenses, here's where you put the license key in for any options. And last page, reference position. So this is where it does these cursors. So I don't remember what these did. I know I've set these up before on other meters, on other scopes. It's how you push in the triggers and that. We can't remember them. Power on line disabled, so when you turn the power up, when the power comes on, you decide whether or not this is going to turn on by itself. I think that's what it does, remember rightly. AWG is currently greyed out because it's not enabled. The license isn't there and the hardware is not plugged in. When you plug the hardware in, the option will become available. You can try it out. And it's the web server setting stuff. So you can set a password for the web server, and so you get into that. And actually there was something else somewhere. Yeah, I have to look into that, but so if you've got segmented memory set up, this will show the segments, however many you've got selected, and list them if you do a list view, or you can step through them as well. So each trigger you'll save a new one, new snapshot, or you can go through that way as well. Because I've only got a couple, it doesn't really matter right now. There was, I think it's under the require menu, wasn't it? Sequence menu, number of segments. Oh, I'm not sure why I can't adjust that. Is it because I've not got it turned on yet? No. I need to figure out how to use that. There we go. So I guess if the time base is long enough, you can increase the number of segments. It depends on how much memory I guess it's got, I suppose. Okay, so when you're doing the segmented memory, the number of segments you have will also depend on your memory depth. So the greater your memory depth, the less segments you can save it as, depending on your time base setting. Alright, so stop that. Go to history. Now do a list view. There should be stuff there. Right. So now you can actually go through the list, step through and get each segment, and it'll display. Oh, in this case, it's all going to be exactly the same because it's a consistent waveform. Alright, but so yeah, that's what it's done there. But again, that's a feature I don't use. That's one I familiar with. You can also step through each one as well, forwards and backwards, or stop it. And navigation. You can do it by history frame as well, and then you can step through by frame instead of by time. But so in this case, they're all going to be the same. Right, okay, that's the history. Decoding. Now this has got two decoding setups on there. Protocols, which are built in. I2C, SPI, UART, CAN, LEN. You can choose the signal levels, or the thresholds and the channels you're using, the inputs. If you've got digital channels set up on the MSO, you can use those as well. Obviously in this case I don't have the MSO option here with me, so I can't actually do that. Still an auto. Let me go back to, let's go back to the default setup. Hold on a second. Clear it all back up again. So back to decoding. So you've got the signal levels, as I said before. You can choose what they're doing. You know, SDA, because there's particular type. Let's go back to let's do an SPI instead. Then you can choose the SPI options there. You know what channel you're going to use for each one. Chip select and stuff like that. You can do all that there. So that's where you set all those up. Alright. Configuration. So you can choose the type of data, how it's handling it, you know, by order, length of data. So you can customize that. So let's go down to 4 minimum after 32. So yeah. Display on. So under here it will now display the serial data. I should really hook up a test unit to show you this decoding actually working using these two scope inputs, obviously rather than digital, because digital was not connected. So I'm going to set our test up, and we'll set up something, we'll shove something into it. Okay, so what I should actually do is show you these probes and stuff too, shouldn't I? 'Cause it comes with two probes. In this case, they're 350 megahertz probes, and you get the accessory kit as well, which has got the coloured collars on the end, and you've got the spring clip there for the ground plane, adjustment tool there for the compensation, BNC adapter, right, and obviously there's the probe, right, hook clip on there. So I'm going to use this and the other probe, which is obviously set up identically, and I'll hook these up to a test box and I'll show you some serial signals. So I've already done through and configured it and got some display going on here. So I've just got a single capture, and here's decoding working here saying Siglent S. It's got Siglent and then it's got a few characters after it, which are just basically what this demo board is configured to do. It's a Siglent demo board I'm using here. And there you go, it's a Siglent and so on, right, and some characters. That's all normal. We'll just do normal triggering. It will just keep on popping up with the latest data. Now, if I go back to decoding here, you've got formats as well. So obviously I'm displaying an ASCII right now. I can do binary instead, decimal or hex. I mean, if I do binary instead, let's have a look at this. What do we get? Do a single capture. So there's the binary version, decimal version, hexadecimal version, and obviously the ASCII there. So you can actually convert after you've done a stop as well. You can also list decode 1, and there's a list there of what it will capture. There's a way of setting this up. I don't remember how to do it, but that's okay. Go into SPI instead. I'll change my configuration over here. It should be SPI data. My signals probably aren't set up right there. I've got my trigger off screen right now as well. Okay, so I've configured it for now for SPI instead. And I'll show you the settings. I'm still obviously doing ASCII decoding there. So SPI, signals, so I've got clock, which is channel 1 currently, threshold set. MSO channel 2. I've also got MOSI set at channel 2 as well, because it doesn't really matter. Thresholds are set. And because you only got 2 inputs, you have to use a chip select option, which I'm using a clock timeout for. You can see it's triggering on the clock there, not on the data. So we can change this timeout here to change the clock timing in order to make sure you capture the data with only 2 inputs. Right, and you can zoom out a bit there. And you can set MSB, LSB again. Now in this case it's MSB. Turn the decoding off. And so there's the data in there, with the random data after the word Siglent, which is what it's supposed to be. And again, you can turn it on and off and shove it down there if you want. Now there was that list view, which is over here, which I did turn off. You can choose which data you want to use, because you've got 2 decoding types you can set up, decode 1, decode 2, and you can then display the data in here from those decoding types, and how many lines you want to have, and what kind of decoding you want. Right, so depending on how you configure it. So that's that stuff. Have I covered everything yet? Shall I do another data type? I think we should. Let's do UART, shall we? I'll go and set this up. Okay, so you can see I've got the UART set up now. Signals, I'm only using one channel because I've only got a single input on it anyway, so I'm using that as TX on channel 1 there. You can set either channel on either one. Set the threshold here at 2.8 volts, just what works for me. Configuration, this is currently using 9600 baud, data length, odd parity, 2 stop bits. This is because this test board is what it's outputting. High level idle, and MSB first, which is just the configuration for this particular kind of data. I've done a capture and I've just stopped it for now because I just did a single capture with this data here. I can actually zoom into one, push that, and you'll see the data's under here. If I hide that menu, it might be a little bit easier to see. And we'll zoom in, and there we go. It says Siglent. I don't know why. I hate the way it's actually got these big gaps in this. You got the quote marks around it. If I took the quote marks out, I could fit more data in. You know, it's like there's a quote and there's a dot, and there's like, it's a bit annoying. In this particular instance, it's not that bad, but in other circumstances, having the quote marks takes up valuable space and seeing what the data is. You don't need the quote marks in there, it's inside a little box. So Siglent, if you see this, remove the quote marks because they're superfluous, you don't need them. So as you can see, it says Siglent, or Siglent, and I've got to scroll over, oh, going on, wait. Scroll to the right, and it says Siglent, and it's got the other data over here, the trailing data. Well, finishes. That's decoded correctly. Let's just center that again, it's easier. Alright, so that's that zoom feature. So again, you can see the data from a distance, and then zoom into the bit you want to look at in more detail. That's the beauty of that. And also, when you got it zoomed in, you can then still do this to it in order to change the zoomed area. So that's decoding covered. I don't think I need to do any more with that. I've done it to death, really. What else can we look at? Oh yes, we need to look at bandwidths and stuff like that. This is a 350 MHz, so we do need to put it through its paces a little bit. So let's chuck a signal on it and see what happens. Okay, so here we go. I've got the scope set up now. I'm using the Siglent SDS2352X, which is another piece of gear I'm going to be doing a test review on. I've had to play around with this a little bit already, and it's pretty cool. So I'm going to use this to demonstrate the scope. So this will be in a review video coming up as well, probably fairly soon. It'll be probably the next one I do. I'm not sure yet. So watch out for this video coming up. Now, so what I'm doing here, I'm generating a 10 MHz signal. You can't really see it too well because of the angles and the high brightness of the lighting I've got going on here and stuff like that. So it's not the easiest to see right now, I'm afraid. Purely just because I've got it all set up. In real life, it's fine, just because they've got really bright lights here. So 10 MHz, I've got modulation. I've got 50% modulation on 1 kHz AM, and that's what I'm generating. Okay, so this is a typical AM waveform. If I increase that rate there, you can see the actual carrier waveform there. Right, so that's a 10 MHz signal which will be coming up in there. If I turn the modulation off, there's the clean waveform there, and it should get the frequency up here. There you go, 10 MHz. Also, I've got the statistics turned on. Let's turn this off. And so there you go, 10 MHz here as well, the measurements as well. And the RMS value is showing as 1 volt. And I'm doing 13 dBm, which is 1 volt. So this stuff you get, this has got the true 50 ohm input impedance. Alright? So if I turn that into 1 mega ohm, it does actually change. Okay, so you can actually hear the relay clicking as well. So it's actually loading down like it's supposed to, so that's fine. So let's go back to modulation back on again and speed it back up. Get a nice waveform. Now you can see the triggering is not wonderful on this. That's because you need to do a few little tweaks. Right, so go to the what I'm going to set up for trigger. Push the button properly. Hold off time. Now, if I normally it's no hold off, that's typically what I used. Put hold off on there and adjust the timing. You get to a certain point and it will stabilise. There you go. So now I've got a nice solid waveform to look at. Right. Let's say you get an AM signal to stabilise nicely. You just hold off and it just fixes that triggering time for you. It's quite nice. So if I do persistence as well, the colour grading, you can also get this effect as well. Right, you don't have to use persistence, but you can just use colour grading. Right, it's nice enough, I suppose. Turn persistence back off again. This colour grading alone can be quite helpful. Persistence is nice for finding instantaneous little glitches here or there, or just show up. It's nice for that. If we do dots instead, it probably won't change much. Right, colour grading back off again. Personally, I don't tend to use colour grading. It's been helpful a couple of times, but generally I don't tend to use it. Waveform looks good on that. No problems at all. Alright, so let's turn the AM modulation back off again. Let's go back to 50 just for the sake of completeness. Different ways of doing stuff. Modulation back off, so it's got the basic carrier, 10 MHz right now. Right, so 10 MHz carrier, and we're measuring 1 volt RMS. Right, basically bang on. So what we need to do to find the 3 dB point is we just increase the frequency until it drops to 0.707 volts. Right, that's the 3 dB point, it's 0.707. And that'll tell us what its theoretical bandwidth is. Now I don't have any limitations turned on this, there's no filtering or anything on there, that's all currently off. So I should be able to just go to the frequency on this and wind that up. So we'll just wind it up like this, and we'll see where it comes out. We'll just watch that voltage level. This is probably going to be a little bit lost in this cable, so that probably will affect it to a point. Anyway, let's go up. So 990 millivolts, 100 megahertz. Let's go over here. Here we go. This is 10s now. Eh? Let's tidy this up. Let's go on 10 megahertz. Now it's getting a bit small. So it's 0.97 millivolts right now, 200 megahertz. Sorry, 0.97 volts. So it's still well within spec there. 300 megahertz there, still 0.9, plus 331 right now. Yeah, 300 megahertz is 0.95 volts. Let's go some more. Put my trigger points a bit. I'll shove it in the middle. Okay, so it's 350 megahertz is 0.86 volts. So that is actually exceeding spec already. So 707 is, let's call it there, shall we? That's 418 megahertz. So 418 megahertz is the 3 dB point, yeah, thereabouts, which means it's got, you know, near enough 420 megahertz bandwidth, not 350. So it meets the spec, easily meets the spec. Alright, so let's just keep on going and see what we can actually read on it. Let's keep going up. Frequency counter still reading frequency there, 460 right now. Keep going, 500. See, it's still usable at 500. Obviously our levels dropped down quite a lot now, it's now 0.36 volts. Let's do that and maybe see it a bit better. But that's a 500 megahertz. Let's keep going. It's 550. 600. It's now reading 190 millivolts, so that's way down signal level wise, but it's still seeing a 600 megahertz signal, and the counter's still working. So let's keep going. 700. Frequency counter's still working. It's reading 120 millivolts. So 750 or so. About 740 megahertz, it's down to about 100 millivolts. That's 1/10 of its standard value. And frequency counter is now struggling to work, I think, or is it just because the level's a bit low? Yeah, now put the level up, it's reading again, 720. So 750. It's trying to struggle because that's the hardware frequency counter. So that's yeah, if I put the levels right up, it can still read 750. Okay, keep going. 800 megahertz. You can see it's getting a bit noisy there. It's really struggling. That's only 47 millivolts, and the frequency counter's basically given up now. But that's still more than double its spec. Alright, so yes, you can read a signal which is a lot higher than the spec. Let's drop this level down again. Alright, so I'll wind it back down. So that's 500 megahertz there. Yep, cool. So let's put it down to, say, 1 volt division or 5 millivolts division. There we go. So that's back in its normal range again there. Well, you can watch it diving down. 700 meg, 800. You know, so it's still there. Oh, and it's just about gone. That's 1 gigahertz. Let's wind this up. It's in the noise. Look at that. But it's there. Turn it off. There you go. See? Yeah. Obviously, you can't use it there. That'd just be ridiculous. You can't do that unless you want to verify that it actually is a signal. That's about it. But yeah, that's the Nyquist and stuff will just be no good for it. Nyquist ratios. But even that, and that's 600 megahertz there, and that's like a usable waveform. So that's pretty impressive, really. Right, so basically it flattens out about there. So it's pretty much flat up to 280. Then it starts to dip. Maybe 280, 290. Yeah, just visually going from that. Starts to dip at 300. So 300 up to 300 megahertz basically is pretty much flat. You know, it's significant. You know, there's not a lot to it. Yeah. Oh no, there's a slight variation there. You've got some little wallows in there, but there you go. So yes, it's definitely meets its 350 megahertz spec, and then you can see it diving down there. But you know, 500 megahertz is still usable, which is awesome. You know, that's quite impressive. In fact, you can see it all really. In fact, you can, you know, keep going. So yeah, I think you can say that's pretty good. You know, no concerns there at all. Okay, let's look at the bottom end then. So obviously that's the high end. It's still, that's pretty flat. That's like 980 millivolts. Yeah, 300 kilohertz. It's still pretty much flat. It's just, I was at 980 or so there. 100 kilohertz, 960. There we go. Levels just dropped down. Below 100 kilohertz has dropped down to 9 dBm. So it's also changed levels there. Obviously, so this thing here is doing that. So that's impressive bandwidth on that. It's pretty even all the way through. Have I missed anything? I mean, I don't know. Do I need to show you the CalCert? It's just the CalCert. It's not really that particularly exciting. It's just from the factory saying it's been verified as correct. My measurements here are coming pretty close with this thing, so you know it's nothing really of concern there at all. I think we've pretty much covered everything, have we? But so unfortunately I can't cover the digital aspects and those things, but you know, that's obviously a feature you can get. I think that's enough waffling. So if you want to check out the review on this unit next, make sure you check the future videos, and also the other units I've got there to test, which is the VNA and the SDS1104X power supply as well. I'm happy with this. That's a nice scope. I like it. Okay, so this is the web interface for the scope. Now, this is, in this case, is the IP address I've got set. I've got it hooked into my main network, and I've just gave it an IP address that falls in a range. So yeah, in my case, it's 90. You can configure it to whatever you need it to be, and I can go into LAN configuration over here. This is what I've got mine set up to right now. Okay, so this will obviously, you need to set this to suit your own network. And if you're familiar with networking, that shouldn't be too hard. It's pretty simple, really. It does have DHCP, but in my case, I just shove some settings in because my DHCP's all IP address locked and stuff as well. So this is obviously the main page here. It shows the model, serial number, stuff like that, MAC address, and software version. So I'm currently running R5 version. I'm using this in Firefox. I tried to do this in Safari because I'm on Mac, you see. I'm using a Mac. So Safari, it kind of worked. Not properly. The instrument control was a bit weird. It just didn't quite work right. So it's got some glitches in there for Safari. But Firefox seems to be working absolutely fine. So obviously it's just a Safari thing rather than an instrument problem. So let's go into instrument control. I'll show you now. So this is what you agree to when you first go in. In this particular screen you can't change any settings. However, you can full screen it by clicking on this. And you'll see this little arrow up here. It's not very obvious, but you click on that. That opens it all up. Now in my case it's a bit big, so I've had to shrink it down slightly. So let's do that. Fit it in the window. I've got a 4K monitor, so it all zooms in quite a lot. Here you can control it. So if you want to change settings like this, you just click on that. That's the button, not that. Alright, so these are the actual buttons it shows here. The grey bits are buttons, all the white bits over here. So you can control it from here, normal. I mean, you can hear how quickly that's beeping. Now this is the updating. Now you can see that there is some artifacts here where it's updating, because obviously it's got to transfer the data across the network, and it's not wonderful here. You know, if you're trying to see a fast moving signal, you're not really going to be able to see it in a computer. But if you've got a stable signal, then it's not going to be a problem at all. This gives you an idea of what that's like. Go to a stable signal, you know, obviously looks absolutely fine. Alright, so something to bear in mind if you've got something which is fast moving, don't expect to be able to see it real time on the computer because that's just not practical. At least my network's not allowing it to happen. And maybe if you've got a direct connection between the computer and the scope, maybe the data rates will be a bit faster or something like that. Maybe it'll be a bit better. But in my case, I'm running through my entire network, so not the same thing. So you can change everything on the scope from this screen. You can control it completely. Right, so you want to go into utilities. You can change all the stuff here. You know, the settings, whatever you want to do, like in here, in out. This is where you set up the Lan interface, so I might show you here, shouldn't I? Instead of going to the scope and doing a camera view. So this can use the Wi-Fi unit, right? So do that wireless adapter not detected because I don't have the Wi-Fi dongle plugged in, because I don't have one here for it. So if you were to do that, you could just set it up that way. Because I'm using a Lan interface, I'm in here. Right, this is where you set it all up. Okay, so you have to use this control over here, and you can click on, say, gateway, for example. There you go. And you can change the values and click on that button there to move it across. So, and you do a save as well once you're finished. Alright, so it's pretty much instant. Alright, there's like a fraction of a delay. It's hardly anything at all as far as between me clicking it and changing the actual scope controls. You know, it's very, very fast. Okay, so that's that part. So obviously you can control the scope and do what you need to do. You can do screen captures and save in waveforms. Let's click on one of these. Change the types you want. So here you go, you can save it to a computer. Right. So you can download it to the computer as well if you want to do that. Version update. So yeah, you can download firmware to it. Save captures and stuff like that. So now there's no back button here to get back into the other stuff. I mean, you can click on that, which will collapse it again. I'll have to bring it back down, but you can't actually like click a button to go back to the main menu. So maybe Siglent need to do something about that to actually add an option up here to go back to the home page. Instead, you've got to use the back button on the browser to go back. Let's just normalise that sizing. Now that's obviously the instrument control side. Now you've got Skippy control as well. You can send Skippy commands. Now I'm not that familiar with them. I've had a quick look at it and just tried to figure out some of them. So yeah, IDN. Oh, I wish it's actually submitted on a return or an enter key button, but instead of putting your line in. So yeah, anyway, so I do it that way. So there's an IDN there, or you can things like stop, for instance, and that stops the scope. I'll go back into machine control. And you can see the scope is now stopped. Right. If I do an arm, that will do a single capture. This does one capture, like she does a single. The single light comes on for a fraction of a second and then goes off again. It just does a single capture. There is actually a command list which I've got. I'll have to. Maybe I'll link it in the description or something. Chuck on website. I'm not sure if it's exactly the right one for this particular scope. It's a command list, and some of the commands I've tried work, so it may be fine. But it's some Siglent, so maybe that's worth looking at if you're interested in doing remote control using Skippy. But I think generally, if you're going to use web interface, then this is a better way to do it anyway. You know, you can just click on these, which changes the effectively. That's turning the dial anti-clockwise and clockwise. Just do a run. And if I click on that, it's like pressing the dial, which gives you a zoom in this case. And then you can still adjust it, and like in this one, I can zoom in. I've got the audio waveform and the carrier waveform. And it shows both in that instance, which is quite nice. So it does everything the scope can do on the front panel. So I shot a video and realised a couple of things I kind of missed is the BODE plot thing, which is quite an important feature. So I better come back and reshoot this. And it's also got this in-out feature as well, I didn't go into either. So this is the inputs and outputs and things it can do, and networking stuff, so no Wi-Fi plugged in, IP setup and stuff like that. It's all in here for the network. I forgot to cover those bits. Alright, so you can set up the IP address and subnet mask and gateway address all in here for doing the networking on the LAN port. Right, so I missed those as well. I don't know how I missed that stuff, but I did. And this is the USB device settings. I think you've got a choice of one right now. But BODE plot is the main thing I want to go into. I don't have anything set up here to actually do a BODE plot. You can figure this, and you need the AWG on this for this feature, I think. I need the AWG plugged in and using that. So as I don't have that, I can't actually demonstrate it. But say, look at the video I did for the SDS1104X-E. I do show the BODE plot thing there. I show the AWG and those features that I can't show right now because I don't have the unit with me. But if you look at that video, it's exactly the same. It's no different. It'll be the same. So you've got your options. You're actually making sure you get hooked up, sweep stuff, you know, better spans and you know, yeah, it's all adjustable as you would expect. Obviously the resolution will depend on how fast it can do it. Linear and logarithmic. It's all the same as the other unit. So, but I just wanted to make sure that I actually showed that it actually has these things in here because I completely missed it. So I thought I'd better come back and re-record that. So it uses these tube channels on the front to do this plotting and stuff, but because I don't have the AWG set up, I can't actually sweep properly and do the actual sweeping in the right way. The AWG has to generate a signal and then the sensor signal. One is the reference from the AWG, the other one is used to check the phase. I demoed it, I think, on the other review. So what's this minimum time on this thing? I didn't look at that, did I? So that is 500 picoseconds, and the minimum voltage 500 microvolts. Make sure you subscribe, click the bell icon to get notifications about future videos, especially when I see my future reviews and the other Siglent equipment. Share the video to your friends, Twitter, social media, wherever you want to put it. Just share it out there, let people know about it. You know, it all helps the channel. Give us a thumbs up if you liked it. Give us a thumb down if you didn't. If you give us a thumbs down, put in the comments why you didn't like it. I always like to know, you know, people's opinions on things. It's nice sometimes to actually get even constructive criticism. It's okay, as long as it's not just abuse. Abuse I don't tolerate. I'll just delete you and ban you from the channel. Abuse isn't acceptable. Constructive criticism is absolutely fine. Thanks for watching. Catch you later. Thanks Rob for this. Obviously I have to give it back, but you know, thanks anyway. Make sure you share this video, put it on, you know, social media or whatever, share it with your friends that might be interested in one of these scopes or if they're looking for one of these scopes. The model number's out of the way, you can't see it, can you? Oh, that's not right. Here you go, that's what I should have been doing, see that?